The first stage of refining is degumming, a process designed to remove phospholipids, the gummy substances naturally present in all crude vegetable oils. The journey begins the moment a tanker truck carrying crude vegetable oil arrives at the factory's dedicated raw material receiving area. As each vehicle enters, it is directed onto a weighbridge, a large industrial scale embedded into the road, to precisely measure the quantity of raw material being delivered. Before any oil is unloaded, trained quality control technicians extract samples using calibrated probes from multiple points within the tanker. As each vehicle enters, it is directed onto a weighbridge. These samples are immediately carried to the on-site quality assurance laboratory for thorough testing and analysis. Inside the laboratory, the crude oil is tested for free fatty acid content, peroxide value, moisture, color, and overall purity before any production begins. Only after passing every laboratory test is the crude oil approved and transferred through large stainless steel pipelines into temperature-controlled storage tanks. The approved crude oil is stored in sealed, nitrogen-blanketed stainless steel tanks, carefully protected from oxidation until it is ready for refining. Nitrogen blanketing systems continuously protect the stored oil from atmospheric oxygen, preserving its quality from the very first moment of storage. The first stage of refining is degumming, a process designed to remove phospholipids, the gummy substances naturally present in all crude vegetable oils. A carefully measured solution of food-grade acid is added to the crude oil inside the degumming vessel, hydrating and separating the phospholipid compounds. The mixture is continuously agitated at controlled temperatures, causing the gums to hydrate, swell, and begin separating from the oil phase. The mixture is then fed through high-speed centrifugal separators, which use centrifugal force to cleanly separate the heavier gum phase from the lighter refined oil. The removed gums are continuously discharged and can be further processed into lecithin, a valuable food-grade emulsifier used across the food industry. The degummed oil now enters the neutralization stage, where free fatty acids, responsible for poor flavor and reduced smoke point, are chemically removed. A precisely calculated sodium hydroxide solution is added to the oil, reacting with the free fatty acids to form sodium soaps that can be easily separated. The reaction between the alkali and the fatty acids forms soap stock, a distinct phase that separates cleanly from the refined oil inside the vessel. Centrifugal separators again remove the soap stock phase continuously, leaving behind clean, neutralized oil ready for the next stage of refining. The neutralized oil is then washed with hot water, removing all residual traces of soap and alkali before a final centrifugal separation clears the wash water completely. The bleaching stage targets the natural color pigments remaining in the oil, chlorophyll and carotenoids, using a highly absorbent bleaching earth mineral. Bleaching earth, a finely milled, acid-activated clay mineral, is carefully metered into the bleaching vessel, where its enormous surface area absorbs color pigments and impurities. Under vacuum conditions, the oil and bleaching earth are mixed thoroughly, the clay particles binding tightly to color compounds, oxidation products, and residual impurities. The oil and spent bleaching earth mixture is then pumped through large pressure leaf filters, which retain the spent clay while allowing the clean, purified oil to flow through. The oil emerging from the bleaching filters is noticeably lighter and cleaner, but volatile odor and flavor compounds still remain, requiring one final critical refining stage. The deodorization column is the most critical piece of equipment in the entire refinery, operating simultaneously at high temperature and deep vacuum to strip the oil of all remaining volatile compounds. Temperatures inside the deodorizer reach between 230 and 270 degrees Celsius, while vacuum levels are maintained at less absolute, conditions precisely engineered for complete volatile removal. Jets of live steam are sparged continuously through the oil, stripping the volatile flavor and odor molecules out of the oil and carrying them upward in vapor form. The stripped volatile compounds are captured in a scrubbing and condensing system at the top of the column, preventing any release of these compounds into the atmosphere. The oil that emerges from the deodorizer is fully refined, clear, neutral in flavor and odor, with a clean natural golden color ready for final preparation before packaging. At this stage, small amounts of natural tocopherols, vitamin E, are added back to the oil, restoring antioxidant protection to safeguard quality throughout the product's shelf life. For oils requiring crystal clarity at low temperatures, a winterization stage slowly chills the refined oil, causing waxes and high-melting fats to crystallize and separate. The cooling is performed gradually and with gentle agitation, encouraging the formation of well-defined crystals that can be efficiently removed through fine filtration. The winterized oil is filtered through fine systems that capture the solidified wax crystals completely, producing an oil that will remain brilliantly clear even at refrigerator temperatures. A final polishing filtration step removes any remaining trace particles, producing oil of absolute clarity, fully refined and ready for the packaging line. The fully refined oil is transferred to final holding tanks, stainless steel, temperature-controlled, and nitrogen-protected, where it awaits the packaging line. The packaging hall is the heart of the factory's output operation, a controlled, pressurized, hygienically managed environment where the refined oil is transformed into finished consumer packets. All personnel entering the packaging hall follow strict hygiene protocols, including dedicated cleanroom garments and air shower decontamination to protect the product from any possible contamination. The packaging film is a sophisticated multi-layer laminate, combining structural strength, an oxygen and light barrier, and a food-grade heat-sealable inner surface, all in a single roll. The film feeds from the unwind station through a series of precision tension rollers that maintain consistent film tension throughout the entire forming, filling, and sealing cycle. The film passes over a precisely machined forming collar, a metal guide that wraps the flat film into a continuous tube shape, the first step in creating the pouch structure. The two edges of the film tube are brought together and heat-sealed along their full length, forming the continuous back seal that gives the pouch its tubular structure. Heated cross-sealing jaws then clamp across the base of the tube, forming the bottom seal of each pouch under precise temperature, pressure, and dwell time, creating a fully hermetic bond. With the bottom sealed, the filling system dispenses a precisely metered volume of refined cooking oil into each pouch, whether 500 milliliters, 1 liter, or any specified target volume. The top seal jaws close above the filled oil level, forming the final hermetic seal and completing the fully enclosed pouch. The same top seal simultaneously becomes the bottom seal of the next packet in the sequence. A cutting blade separates each finished sealed packet from the continuous film tube, releasing it cleanly onto the takeaway conveyor as a complete individual product unit. An integrated date coding system simultaneously applies the production date, best before date, and lot number onto each individual packet, enabling complete traceability from finished product back to raw material. Finished packets flow continuously from the packaging machines along the conveyor system toward the inline quality inspection stations, each packet identical in size, shape, and seal quality. Every single packet passes through a high-speed check weigher, which weighs each one individually, in motion, confirming that the fill volume meets the precise target specification. Any packet falling outside the acceptable weight tolerance is automatically diverted by a reject gate, ensuring that only correctly filled packets of the right volume continue forward on the production line. Seal inspection cameras examine the integrity of every top and bottom seal, automatically rejecting any packet with an incomplete, wrinkled, or compromised seal. Vision systems verify that the printed date code on every individual packet is present, correctly positioned, and fully legible, automatically rejecting any packet where the code is missing or unreadable. Packets that have passed every inline quality check are automatically grouped and collated on the conveyor, organized into precise counts ready to be packed into outer cartons. Flat carton blanks are automatically fed into a case erector machine, which folds, forms, and seals the bottom of each carton with hot melt adhesive in a rapid and continuous sequence. A pick-and-place robotic arm lifts groups of finished packets with precision and places them into waiting cartons in an exact, organized arrangement, determined by the product's commercial specification. Once loaded, the carton top flaps are automatically folded closed and sealed with hot melt adhesive, enclosing the packets securely inside a robust outer carton ready for distribution. Each sealed carton is marked with full case identification information, including product description, net quantity, lot number, production date, best before date, and handling instructions. Every sealed carton passes through a final weight verification check, confirming that the correct number of packets is present inside each carton before it proceeds to palletizing. In the palletizing area, a large industrial robotic arm lifts each sealed carton with precision and builds a stable, interlocked pallet load, layer by layer, at speeds no manual operation could match. Each carton is placed with exacting accuracy, following a pre-programmed stacking pattern that alternates orientation between layers, creating a stable, transportation-ready pallet structure. The fully built pallet moves automatically into a stretch wrapping machine, where transparent film is wound continuously around the entire load, securing all cartons firmly and providing protection during transport. The stretch film also provides tamper evidence. Any unauthorized disturbance to the wrapped pallet will be immediately and visibly apparent during the distribution and retail journey. Each completed pallet receives a barcode identification label containing all product, batch, and traceability information, linking every pallet to the specific production batch from which it was made. Finished pallets are transported directly to the finished goods warehouse, where they are assigned to designated storage locations and managed by a fully automated warehouse management system. Inside the finished goods warehouse, thousands of pallets of completed product are stored in a precisely managed inventory system, tracked by location, batch number, and production date to ensure correct first-in, first-out dispatch. Running parallel to every stage of production, the Quality Control Laboratory draws finished packet samples from the production line at regular intervals for comprehensive finished product testing. Color measurement using a standardized colorimeter confirms that every batch of finished product meets the required color specification, a direct reflection of the effectiveness of the bleaching and refining stages. Clarity and appearance assessment confirms that the finished oil is free from haze, cloudiness, or suspended particles, meeting the visual quality standards that consumers expect on the shelf. Stability testing is conducted on retained samples from every production batch, stored under defined conditions and tested at regular intervals to confirm that the product will remain fully within specification throughout its entire shelf life. The laboratory's hygiene monitoring program regularly swabs production equipment, pipework, and surfaces, testing for any microbial contamination that could compromise product safety. All laboratory results are recorded in the factory's quality management system in real time, and any out-of-specification result immediately triggers a product hold and a formal investigation before any release is permitted. The factory's central process control room monitors the entire refining and packaging operation in real time, with automated systems tracking every critical parameter across every stage of production simultaneously. Every process parameter, temperature, pressure, flow rate, dosing volume, and separator performance, is continuously monitored and automatically controlled to maintain the highest possible product consistency. A dedicated maintenance engineering team keeps every piece of equipment in optimal operating condition, conducting planned preventive maintenance programs that prevent unplanned downtime and protect product quality. All process vessels and pipework are cleaned using automated cleaning-in-place systems, delivering validated cleaning agents at precise concentrations, temperatures, and contact times without the need to dismantle equipment. The comprehensive pest control program, managed by specialist contractors conducting regular inspections and maintaining physical and chemical control measures, ensures the facility remains fully protected against any pest risk. At full production capacity, multiple packaging lines operate simultaneously, each machine producing hundreds of finished packets every hour, day after day, with an unbroken standard of quality and hygiene. Every single packet that leaves this facility is the product of a precise, multi-stage process, refined, filled, sealed, inspected, and verified to an exacting standard of quality. From the packaging lines, finished cartons travel automatically along elevated conveyor systems to the secondary packaging and palletizing zones, the product moving seamlessly through every stage without manual handling. Viewed from above, the scale and integration of the operation becomes clear. A single, continuous automated flow that carries the product seamlessly from packaging machine to finished pallet, without interruption. Each completed pallet represents the cumulative output of every stage in this remarkable process, from crude oil tanker to finished, verified, ready-to-ship product. The warehouse management system tracks the precise location, batch identity, and production date of every single pallet in the warehouse, ensuring product is dispatched in strict first-in, first-out sequence to protect shelf life. When dispatch orders are received, finished pallets are retrieved from the warehouse and loaded onto distribution vehicles, ready to begin their journey to retailers, wholesalers, and ultimately to the consumer's kitchen. From this perspective, the true scale of modern food manufacturing becomes visible, an integrated, automated, and precisely managed operation dedicated entirely to producing one essential product to the highest possible standard. This is the finished product, a precisely filled, hermetically sealed, fully tested, and quality-verified cooking oil packet, the result of raw material, refined science, modern engineering, and unwavering quality standards working together. Modern food manufacturing has made safe, affordable, and high-quality cooking oil accessible to millions. Behind every pack in my refrigerating quality, a quiet achievement of modern industry that deserves far greater appreciation than it receives.